Thank you everybody for joining. Thanks for coming to this session. I'll start by talking a little bit about who we are, why we exist, and then dive right into the technology. In terms of the company, we're 10 years old, started in 2016. The idea behind Vast Data was to create the AI operating system. It's a new software infrastructure layer that's required for these new AI abilities, for these new AI factories. And so we started from storage and then database, and then we're adding all of the parts required as part of that software infrastructure in order to enable agentic workloads, AI workloads, training, inference, fine-tuning across the board. As I said, 10 years old, we announced last week a few numbers. We had a new funding round, round F, at a $30 billion valuation. We're the fastest software company to get to more than $4 billion of cumulative software sales over the last 6 or 7 years since we started selling. And we've done so very, very efficiently. And so not just growing very quickly, about tripling year over year, but also generating cash, also being profitable. For those of you who know the rule of 40, which tries to show the trade-off between growth and profitability, our rule of 40 is 228%, so significantly higher than anybody else out there. And we needed to build a new type of architecture in order to do this, which I'll explain in a few slides. But before diving into what it is that we've built, maybe looking at some of the customers, some of our partners that are using this technology across the different verticals. And so you find everyone from government and defense. We'll talk a little bit more about HTX here soon. But in the US, places like the National Labs, Los Alamos, NASA, leading HPC centers across the world like Texas Advanced Computing Center and Chinica, technology leaders, not just in the AI space, companies like xAI and Alfalfa, but also more traditional technology vendors like LG and ServiceNow. And so we're across the board. Wherever you find a lot of data and wherever you find AI, that's where we operate. We're trying to build this new stack with a lot of partners across up and down this new technology place. The one that I think is most interesting is these AI clouds. The biggest one in the world right now is CoreWeave. They have standardized on our stack, as has Lambda and Scaleway in France. There's a couple that are in this region. Well, Core42 is global out of the Middle East, but SK Telecom here in Korea, not far from here, GMI based out of Taiwan. It's a new form of what's known as sovereign clouds. And they're building not just the AI stack, but they're providing it in country in a sovereign way for local organizations and governments to consume. Over the last 3 to 4 years, we've partnered with nearly 100 of these new AI clouds. And as they build out the stack, they realize hardware comes from great companies like NVIDIA, but then we need the software infrastructure layer that takes advantage of that hardware and makes it accessible to these new models and applications on top. So what does that stack look like? We have the old stack for business systems and we have the new stack for AI. And what we're realizing is that there's a big data divide between the two. The old stack was all about numbers and columns of a database. And the analysis was done by CPUs that weren't that hungry for information. The new stack, we're now analyzing pictures and video and sound and genomes, natural language that tend to take up a lot more space in terms of capacity. And we're using tens of thousands, in some cases, hundreds of thousands of GPUs that are very hungry for information in order to analyze this data. And so we need new infrastructure in order to support that. It starts with storage. We need fast access to a lot of data. But once we have that storage layer, we realize that's not enough. We need a full-fledged data platform that includes unstructured data and structured data in a way that makes all of this information accessible to these AI systems. And we needed to bridge between the old world and the new world, such that these new AI workloads can actually have access, fast access, to the entirety of the historical data that we accumulated. And not just in one location, but across geographies. And so if you have multiple sites around the world, we want you to be able to put a vast instance in each one of them, and we will build what we call the vast data space, one global namespace across geographies, in order to provide a global cloud. But what we're really building is this new type of operating system. It's not within a computer, it's not even within the data center, it's across locations. It works within public clouds, AI clouds, edge locations, on-prem, and then we're now going into devices. You'll see around the conference robots and cars and drones and satellites. All of those require this new AI operating system in order to function. And it consists of a few parts. The first part, where we started from, is very, very large-scale storage. And what we realized was that the old systems were not fast enough, were not big enough, were not resilient enough, they weren't cost-effective, and they were very, very difficult to use. And we needed to break that computer science trade-off in order to enable this new era of AI. We started 10 years ago, on the same month that OpenAI was founded, in the same year that NVIDIA provided the first DGX-1 to OpenAI. And so the different layers of the stack, the hardware underneath us, the models on top of us, have been building in parallel. And our part, first and foremost, was to provide fast access to a lot of information. But very quickly we realized that that's not enough. What we now call the vast data store is just the first part of this operating system. Very quickly we understood that we need to have a solution for structured data, which includes metadata, describing this unstructured information, and includes other forms of insight that we can generate in order to understand the natural world. And so as a picture, for example, comes into the system, it has metadata associated with it. Where was it taken? When was it taken? And the resolution, the camera, the location, all of these things now sit in the vast database. And as we run that picture through an inference function, we understand more about it, both human-readable metadata, who is inside that picture, as well as machine-readable metadata, as we vectorize these things and provide the ability to find similarity across the namespace. All of that resides in the vast database. And in the same way that the storage systems weren't big enough and weren't fast enough, the database systems weren't big enough and weren't fast enough. I'll give an example today about what we're doing with HTX, but as an example, from a vector database perspective, 100 million rows or even 1 billion rows is no longer enough. If you have 50,000 cameras and every picture that comes in requires its own vector embedding, you need a 1 trillion row database. And you need the ability to run similarity search across those 1 trillion vectors. And so a new architecture is required for the storage system and for the database system. And this architecture that we built that broke that trade-off between price and performance and scale and resilience and ease of use is being used up and down this technology stack. And so the database today is no longer being read or queried by people. It's being queried by agents. And we don't have 100 agents, we have 100,000 agents. And we will soon have 100 million agents, all wanting to understand what's going on at the same time. And so you need extremely fast parallel access to very large amounts of structured data. That's where we became the data platform for this AI era. And that was about 4 years ago. As we added more parts, we're now truly the AI operating system. And what makes us that is the data engine. The data engine is where we start to orchestrate compute, but not in the old way of running VMs or running applications, but in a new data-driven fashion. That picture that comes from the CCTV camera, that picture should trigger that inference function so that we can understand what's inside of it. And when we recognize a face in that picture, that should trigger another function because maybe that person is missing. We need to know where they are. And so this becomes a recursive machine where we can add more and more abilities and functionality as we manage all of the underlying hardware for these new AI applications. Over the last couple of years, we came out with things called the Sync engine or the Insight engine with NVIDIA or the Agent engine. These are ways for enterprises to adopt AI in a simple and secure way. The Insight engine, as an example, is RAG in a box. You don't need to know that every document that comes into the system gets inferred upon. You don't need to know that that vector representing the document is being placed in our database. All you need is a chatbot interface into your organization's information, where every person within the company or government agency can see the specific documents that are relevant to them and gets answers to those questions in natural form based on the information that they're allowed to see. So based on existing access controls. The Agent engine is really bringing us into this agentic era where we need not just the ability to run hundreds of millions of agents and make them successful, but also the ability to observe. What are they thinking about? What are they doing? What are they communicating to each other about? And to control what data they can see, what data they're allowed to communicate to other agents and to people, and to be in the data path in terms of enforcing policies. This agent is not allowed to spend more than this amount of money, or that agent, which is a physical robot, is not allowed to pick up this tool that could be dangerous. And so the operating system is the layer in which all of this security and observability and explainability gets enforced. Those are the tools that are required for this new era of applications and computation. To give one specific example, we've been working for the last almost year now with HTX. I'm sure you saw their big booth in the middle of the trade show here. They're doing really, really interesting things with cameras, with robots. As an example, they have cameras all around this city-state. And today they're being used for a very specific purpose. But with AI, we can now expand that and do a lot more with those cameras. Here's an example of the architecture that we built with HTX and how they're leveraging the different parts of the vast AI operating system. And so as video comes in, that's stored as an object in our S3 store. And then it goes through our event broker, which is a Kafka interface system that we built ourselves to trigger the various things that happen on that image. And things like facial recognition, things like understanding the environment. Maybe there's a traffic light that is broken and needs fixing. All of these things happen through this inference ability. And after we infer, we fine-tune in order to build a better model over time such that we're better trained on the information coming from these cameras here in Singapore. But in parallel to this work of inference and fine-tuning, what we really want is to deploy agents. We can now deploy agentic systems that in real time recognize the things that we care about most, whether it's a fall detection agent or an accident detection agent or an emergency dispatcher. When bad things happen, we want to see it, we want to react very, very quickly. And these agents, looking at all of this information, can now do so in a much more effective way, in a much more efficient way. So this is just one example of one project here in Singapore that we've been building with the local government. But beyond that, Singapore is the only place that I know of that has a government-led mandate for AI. And recently they came out with a new AI paradigm, NAIS 2.0. And as you can see, these different pillars driving AI in Singapore all align to what vast data provides. And so as we build out new power plants and new data centers and new chips and hardware capabilities. We need that software infrastructure layer to make it easy, to make it secure, to make it possible for all of these new models and upcoming applications, not just to thrive, but to really redo the way we live and the way we run our lives. So thank you very much for having us here today.